to talk to you about laws of exponents. Now you might already know them, but they are very important all throughout your school career. So it's good to know them by heart and be able to apply them in any situation. So the first one is the multiplication rule. So an example is a to the x times a to the y is equal to a to the x plus y. So let's just write that in numbers. For example, if we have 2 to the power of 3 times 2 to the power of 4, that is just equal to 2 to the power of 7. And that's just something you have to memorize, and that will be able to help you when simplifying expressions. Now the next one is a to the x divided by a to the y is equal to a to the x minus y. So same thing here. Say we have 2 to the 4 times, divided by, right? So let's write it like this. 2 to the 4 divided by 2 to the 3. It's the same as writing 2 times 2 times 2 times 2 divided by 2 times 2 times 2. And now you can already see 2 and 2 crosses out, 2 and 2, 2 and 2, and you are left with 2 to the 1, which is also 2. Next one, a to the x in parentheses to the power of y is the same as a to the x times y. Now where this comes in helpful is if you have something like this. Let's say that you get 4 to the power of 2. Now 4 is the same as 2 to the power of 2. And now the whole thing to the power of 2. So now you can rewrite it as 2 to the power of 4, because 2 times 2 is 4. Or let's put a different example. Let's say 9 to the power of 2. And that is equal to 3 to the power of 2 to the power of 2, which is 3 to the power of 4. So next we have the power of a product rule. So a times b to the power of x is a to the x times b to the x. And that also helps you when you have to simplify expressions. So if you, for example, have 2x to the power of 3, it's the same as 2 to the 3 times x to the power of 3, which is 8x to the third. Now power of a fraction rule, basically the same as power of a product rule, just that now you apply the x in the power to a and b in the fraction. So you have, let's say, 2 thirds to the power of x. It's the same as 2 to the power of x divided by 3 to the power of x. Zero exponent, so a to the 0 is always 1. Doesn't matter so what you have, so 2 to the power of 0 is equal to 1, or 5 to the power of 0, anything to the power of 0 is always 1. That's also just something you have to memorize. Might seem weird to you why it's that way, but yeah, just try to memorize it. If you really want to understand it, just think of it as multiplying numbers. So if you have, for example, 5 times to the power of 2 times 3 to the power of 1, and you want to keep going and multiply anything that doesn't change the number. So you can now multiply, for example, 2 to the power of 0, and you wouldn't change the result of 5 to the power of 2 times 3, which is 75. So that's why this part here has to be 1. Otherwise you would just get the result of 0. But just because you have a number to the power of 0, which is just usually, let's say, 2 to the 2 is 2 times 2. So 2 to the 0 is just nothing there. But if you multiply nothing there to another number, you can't just get 0 all of a sudden, because you didn't change anything. So that's why this has to be 1. Next we have negative exponent. So a to the negative x is 1 over a to the x. And that's important to remember, because just because you have a negative in the exponent doesn't mean that the whole number all of a sudden is negative. So let's say 2 to the power of negative 3, it's not negative 8. This is equal to 1 over 2 to the 3, which is equal to 1 over 8. If you wanted negative 8, it would just be negative 2 to the power of 3, or negative 2 to the 3, which are both negative 8. But if you have the negative in the exponent, you just have to take the reciprocal of that. And now the last one, a fractional exponent. A to the x divided by y is equal to the y root of a to the x. So the way to remember it, what I like to do is just picture in my head a to the 1/2 is equal to square root of a. So square root is the same as second root, and a is the same as a to the power of 1. And so that's how you can remember where which one goes. So the numerator goes in over the a, and the denominator goes over the root.